All right, welcome everyone to the Infinite Expansion podcast brought to you by the Last American Vagabond. I'm going to be your host once again, Tim. And boy, do we have a show for you today. We got a topic that honestly is not that well known. It's a topic that I've really started exploring the last about 2 months. It has a whole host of implications. I would say it's more of a working theory at this point, but today we wanted to present a lot of the data points that we've been coming across that's kind of leading us to this theory. And to discuss this, I brought on my friend, we're going to call him Jay the Explorer.
Hi there.
He's been on another podcast with me before about 9/11, but we wanted to kind of introduce this idea. I would say call it a working theory, and kind of we're not presenting this as a fact or anything. This is just data points that we've noticing kind of pointing in us in this direction. And so I wanted to introduce this idea for people to look into it themselves and to expand upon it, disprove it if you can. Whatever this takes us. But to start it off, I wanted to throw it to Jay here. Maybe give people an idea of just what we mean by the growing Earth theory and how this differs from what we've been told.
The growing Earth. Boy, this is a brain buster here. So, growing Earth is the idea that the Earth is not a static, fixed volume and mass. It's actually growing. And what led me to this were some animations by Neil Adams, and we can link to these in the show notes. And every little kid can kind of see how Africa and South America sort of kind of look like they fit together, but not quite right. Well, if you take the Earth and shrink it to about 50% of its current diameter, they fit together perfectly. And all the other continents fit together perfectly. If you eliminate the water, shrink the globe to roughly 50% of its current size, all the continents fit together perfectly. And this is illustrated very clearly in these animations from Neil Adams, so I have to thank him for that. And not only the Earth, we see evidence of this on the moon. We see evidence of this on Mars. We see evidence of this on some of Jupiter's moons. Some really good animations on there. I encourage everybody to go check those out, because to me, seeing is believing. If a picture is worth 1,000 words, then I guess a graphic animation is worth 1,000,000 words. But it just shows how the continents just fit together perfectly at a smaller size of the Earth. So we're not talking about simply expanding Earth, and there are alternate theories on that. And the difference between expanding and growing Earth would be expanding just means the mass is staying the same and it's inflating like a balloon. And we're not saying that. We're saying the Earth is actually growing. And so the follow-up question is, if you're saying it's adding mass, then that mass has to be coming from somewhere. And we have some decent explanations of where that mass could be coming from, and it has some pretty earth-shattering, no pun intended, implications. If mass is indeed being added to the Earth, also the sun. If the sun is growing as well, it seems that every celestial body is growing. So I don't know if that's a sufficient introduction.
And how would you say this differs from what we are taught? Like, what are we taught, and how is this different?
Okay. Yeah, well, we're taught. I was probably taught the same that you were taught, Tim. Just that the Earth is a dead piece of rock, and it's got an iron core in the middle of it. It's very hot in the middle. Then as you go up farther, we have molten rock, and on the surface, it's just rock and dead vegetation, and that the life that we have on the planet is due to the sun irradiating the planet with energy. You know, it makes plants grow. We eat the plants, and the plants rot, eventually become oil and such, become the planet we live on today. But we're also taught the idea of Pangea, where all the continents were drifting around at some point. And at one point, they were all together in one massive supercontinent. And for some reason, they split up and started drifting around all over the planet. And then some of them came back together, and they formed what we see today. And that, I guess, in a nutshell, that's kind of what we're taught. We don't really go too much deeper. They get into plate tectonics and plate subduction, which is where one plate slides underneath another plate. But we're never taught that the Earth is increasing in mass. I mean, that's kind of almost a taboo. That implies you're getting something from nothing. And hopefully we can crack through that barrier in this conversation and show that it's indeed not something from nothing. It's something from what is around us all the time. And we're just not taught about it. We're just not aware of it. And maybe that's a good segue into talking about ether and protomatter.
Yeah, in many ways, Pangea is somewhat correct, but on a much smaller Earth.
Yeah,
so
that's an interesting point.
It actually doesn't disprove Pangea, but it expands upon it, and basically Pangea, all the continents were together, but on a much smaller Earth, and they literally pretty much come together on all sides perfectly. And I want to get into the ether in a little bit, but first, what would you say some of the best evidence supporting this theory are?
So the best evidence, what really blew my mind and made me have to give this a hard second and third and fourth look, was Neil Adams's animations. They show how the Earth, if you shrink it to about 50% of its present diameter and take away the water, the continents fit together like puzzle pieces. They fit together 99% perfectly. And to me, that can't be a coincidence. That can't just, they just so happen to fit together on a globe of a smaller volume. To me, that's the best evidence, just seeing how everything fits together. Like, if you wanted to do this on a crude level yourself, you could cut out the continents, put them on a balloon, and have a big blue balloon with paper continents on it, and let the air out of it, and the continents will fit together like puzzle pieces if you can get them to stick onto the balloon. But thankfully Neil's done some really nice animations, just beautiful work there in demonstrating how they all fit together. You can go a lot deeper with this, and there are other researchers that have shown how we have the same vegetation, trees on continents that are half a world apart, and that doesn't make sense if they've always been apart. If they were together I suppose that also supports the Pangea, the classical Pangea on a constant size Earth as well. It does also support that, but to me, it's just graphically, geometrically, how everything fits together. I don't see how you can argue against that.
Yeah, I would say there's some other things for me personally that really made this click. One, if you take our current data, the land can be dated back way farther than any of the seabeds. So if all the land if we had like a landlocked planet on a smaller planet, well, then this would hold true. Now, I don't have a way of verifying all this data necessarily. I'm not, but this is taking the data that mainstream science is using.
Yeah, conversely, the seabeds should be roughly the same age. You know, we're told that we get all the water from ice comets hitting the planet and just flooding the land. So that doesn't explain why the seabeds are so much younger, so much newer than the continental shelves.
Right, and not only are they younger, but they get progressively younger the farther you get away from the land, which would make sense because they split apart farther and farther and farther. And when you get close to the cracks, you and literally they're like almost in the middle of the Pacific and Atlantic. You get younger and younger seabed. And the only, I mean, I don't see a what better explanation than it was cracking. So it's growing, it cracks, and it expands outward from those cracks. And and then the continents don't actually move. They just the land they don't move like plate tectonics on ice or whatever. They actually just expand outwards. And sometimes they crack apart from each other. The land cracks and separates a little bit. The other thing that really got me personally was, so I lost my train of thought there for a second. I lost my train of thought there.
Dinosaurs. Dinosaurs are a good one. You know, you look at the design of dinosaurs, and for example, a T-Rex is, you know, roughly the same weight as an elephant, you know, more or less. But its legs are designed entirely different. An elephant walks around pretty much peg-legged, whereas you know, just to support the massive weight of its body. Whereas a Tyrannosaurus Rex, you know, has these cool running legs. And for that matter, think about a Brontosaurus, some of the really huge dinosaurs. The poor thing wouldn't be able to lift its head today in current gravity. So the lesser gravity of the smaller Earth makes the sheer scale of the dinosaurs makes sense, and not to mention the massive insects that they had back in the day. But we have fossils of, you know, dragonflies that are over 1 meter long. The poor things wouldn't be able to get off the ground in current gravity. And we're given some explanation that it's there was an increased oxygen in the atmosphere. You know, like it. Okay, but how does that help manage the weight? I don't see how that helps manage the weight. In that doesn't make the bones are roughly the same density as the densities we see in modern animals, and so they were made of the same stuff essentially. It's just they couldn't have lived if gravity was the same as it is today, if it was back when dinosaurs were alive. So the lower gravity explains a lot of that dinosaur problem, to my mind.
Also, it explains potentially some of these large monolithic structures like the pyramids or these massive stone monuments that we cannot explain. It also would explain why we find sometimes remains of much larger humans in the ground, because potentially with the lower gravity, we could expand outward more, grow farther. It explains a lot of that. These huge
really
animals.
Does. Makes a lot of sense.
And then, what I remember now is what I was going to say before until I lost my train of thought was, I think it's very naive to think that, so everything seems to be in like this process of growth. Yet we think that the Earth is this static object that is immune to that and doesn't grow. To me, naive and just doesn't go with all these other things that we see going on. And so in that regard, when I think about the Earth just being some static, fixed object, it just goes against so many other things that I've come to learn about nature, the stars, whatever. They seem to all be increasing and growing. That was a big one that kind of made me think, you know what, that's kind of right. I mean, that's kind of, it made me think a lot. Whether you want to believe it or not, it should make you think, I think, about why wouldn't the Earth, why wouldn't it grow? Why wouldn't it seem to evolve like everything else?
Right. Right. Yeah. I mean, that's, you know, almost a metaphysical point, but it does make some sense in that context. You know, why is the sun, you know, we're told the sun is growing, and it eventually will be a, you know, a huge star compared to what it is today. Well, why not the other celestial bodies? You know, could it be that that the Earth will eventually become the size of Jupiter, that it'll become a gas giant, and that Jupiter eventually will ignite and become a star?
Right.
Could be, you
I
know,
think
millions of years, whatever.
Some of the implications of that seem to be that seems to possibly be the process of how celestial bodies form. You have a planet, you go into a gaseous giant as you heat up more and more pair production, so you get larger, and then you turn into a star, and then maybe the star turns into the supernova, and you know, after that. So now let me ask you this.
Yes.
Okay, so those are some of the evidences behind it. Now we'll go in a little bit more to the mechanism of how this seems to happen, but what do you think, what do the skeptics say? Because this isn't necessarily a new theory. It's been around for a little bit of time, but what do the skeptics say on why this isn't true?
Well, it flies in the face of most conventional science. I have a few notes here that it was originally proposed by a geologist named Sam Carey. Gosh, I think it was in the 50s or 60s, trying to explain some of the things he saw, but he wasn't a physicist. So he only got into the fact that, hey, the Earth is getting bigger. I can't explain why, but it does seem to be getting bigger. But as far as the skeptics, it's not what they were taught in school. It's not what all their friends believe. It's not on the news. It's just not in the mainstream. Most people live their lives kind of in the mainstream, and if it's not there, they say, well, we would know about it. Everybody would be talking about this. So honestly, that probably is the biggest factor right there. If all your friends think the Earth is flat, and if you were taught the Earth is flat, you know, in school and in university, and your parents told you the Earth was flat, you're probably going to think the Earth is flat. You know, step paradigm. It takes a bit of courage to step outside that paradigm. But probably one of the big questions that people may have, and I had this question: well, if the Earth is growing, where is this mass coming from? You can't have something from nothing. You know, the mass is got to be coming from somewhere, and it's not readily apparent where that mass may be coming from. So that's probably the biggest biggest hurdle.
Yeah, I think people the process, and we'll get into this in a second, that seems to bring mass to the Earth is the biggest jump for people. They because it involves you know, ether or dark matter or whatever you want to call it. Seems to be the same thing, but it involves this process that we don't quite understand yet, and that is a big jump, and it goes against many of the theories and scientific dogma. I mean, it literally has the potential to rewrite what we know about physics, archaeology, all these sciences that we're taught to believe, and it kind of breaks those open in a way. And for many people whose careers depend on this, and whose funding, in the scientific community, if you don't abide by I mean, you wrap your whole thinking around these theories that you think are facts, when a lot of them are still theories, and we accept all these theories as facts, and a lot of these people aren't brave enough, or their careers depend on it, and so they look,
Absolutely.
or maybe they look, but they don't talk about it.
Absolutely. I mean, if your funding is withdrawn because you're presenting ideas that perhaps threaten the petroleum industry, for example, and funding for your research and your department is withdrawn, well, you're out of a job. Literally, that was your salary. Your salary just went away. So now you're an out of work scientist and you don't have a voice. It's hard for you to get your papers published. If you go against the mainstream, if you upset the apple cart, so to speak, it's really hard to get your voice out there. So there's a tendency to just stick with the mainstream, stick with the accepted so-called settled science. And science should never be settled. Everything should always be up for debate. If we find new evidence, we have to question things. At some point, people thought the Earth was the center of the universe, and that model worked pretty well, for quite a long time. But then more evidence came along, and we had to rethink that. So I think this is as big a paradigm shift, that the Earth is growing and not static, because it involves a whole lot of implications.
Right, and if you think about when those things when those things happened before, these people were persecuted, were like the established system hated these people. They were killed. And so to think that it'd be any different now when these new theories come about, and to think that the established system, that these things aren't going to be really in the underground and they're going to be only pursued by those thinkers outside the system,
right.
It would be naive to think it'd be any different now. People just they don't connect the history of how these things come about, but when they're happening right now, well, no, that can't happen now. We're far more advanced now. No, this is the same thing, just it's more nuanced. It's more new age way. It's not. It's very similar. But anyways, okay. So let's go into a theory of how this seems to be happening. And I want to say before that, look, this is a working theory. There seems to be I think there's definitely some data that people should look into. I would love for people to expand upon this idea more. It's still, we're still working on it ourselves. I just want to introduce the concept more, and have people run with this more. So could you explain a little bit the mechanism for growing Earth and how that seems to be happening?
Yeah, and like Tim said, we're still kind of wrapping our brains around this. The best technical explanation I've heard yet, and I'm sure there are people that can go more technical, is a show that Neil Adams did. We'll link to it in the show notes, on another podcast, and he goes into some detail for about an hour on all the mechanisms. And we're not going to go that deep, but just in brief, we live in a sea of ether, a sea of proto-matter. Atoms are mostly empty space. Well, what is that empty space filled with? So the idea is that it's filled with inward-facing fields. They are essentially electrons and positrons that are paired up together. So they satisfy that positive and negative charge, so you can't detect them with any kind of instrumentation. There's no resulting field from it. It's just a positron and an electron, a positively charged particle and a negatively charged particle, chilling together. They're happy until a high energy photon comes in, crashes into them, and breaks them apart. Now, when they're broken apart in a magnetic field, they can't immediately join back together, and we would call it annihilating. Well, it's not annihilating. Again, if you can't make something from nothing, you can't make something into nothing. They're just joining back together outside of the context of a magnetic field. And in fact, in a magnetic field, most of them do still join back together, but enough of them split apart that they're able to form hydrogen. They're able to form eventually helium, heavier elements, oxygen, and on and on. And this is where the matter comes from. So it's essentially ether or proto-matter. Maybe you could call it prana.
Maybe
Lots
dark
of
energy.
different names. Dark energy. Yeah, lots of different names for this. Even in old religions talked about prana and spirit. I've heard it called spirit. That's fine. It's all around us. We can't detect it usually, but it under the right conditions can become matter when it's essentially bombarded with a high energy field. This proto matter can become actual physical matter. It starts simple. It starts with hydrogen, and then it gets it piles on the toroids and becomes the heavier elements, helium and then oxygen. Which now you got hydrogen and you got oxygen. You put those together and you got water, and that explains what we're seeing in those animations that Neal Adams has done. First we're starting with an earth that's mostly solid. It's mostly rock, mostly dry. There's no water on it. But as it grows, as it expands, you see the oceans emerge. You see water emerging onto the planet and driving this continental shelves apart. Where does that water come from? I gotta think it's from this hydrogen and oxygen forming together.
Right, and this process
way to the surface.
This process is better known as pair production.
Yes,
and this seems to be the only process that we know of that creates matter in the universe. And a lot of people dismiss this, as Neal Adams talked about, because they think it just annihilates. But I think if you go a little further, you see that in an electromagnetic field, they can actually separate and become matter.
right.
And and the other thing is what seems to be ironic here is that, so you have the ether, which we think is nothing, and by this process of pair production, we come to the first element on the periodic table.
Right.
It seems to be, okay, this is the first thing of matter we can identify. And well, that seems to line up literally perfectly with that concept. And so, again, another just kind of data point that seems to line up here.
Right. And I've seen an alternate periodic table. We can put it in the show notes that essentially it describes all the elements as aggregations of fields, of toroids. Rather than, hey, they're just separate elements and that's how they are. So that help explains how they build up into the heavier elements. And that's something I want to dig into deeper. Maybe we can address that on a future show. But so it changes this theory of expanding Earth has the potential to change a lot of things. Chemistry, a big one, which is great for me because I was never that great at chemistry in college. Maybe this new theory will make a lot more sense to me.
And it seems to be, so if you look at Tesla's work, it seems to he have, at least a lot of the speculation seems to see that he discovered the ether and discovered how it worked. And and if you think about free energy, you're thinking about taking this proto matter that we don't think is anything and turning it into energy, which would equal free energy. Right. And so this seems to line up a lot with that. And if you think about the implications to the established system, well, maybe that's why his work was all confiscated. He died penniless and whatnot. And so this would again line up with a lot of stuff that we're told. But in a nutshell, that seems to be a working theory so far as we've come across. There's other stuff that can be added on, but when we're still working on that. But it seems to be the process that we're working on. And I want to drop a lot of links in the show notes for people to expand upon it, approve it, disprove it, whatever. I'm not 100% set on this theory. It's just something that we've been noticing and something that I'm going to keep going. There's a lot of data lining up and a lot of things that we can't explain. And it seems to be tying some of these things together.
It does. It really connects a lot of dots for me. Some other people that are on the forefront of some of this, I don't even know if you call it new science, because a lot of it seems to be rediscoveries of older science that either got left behind or buried for whatever reason. But Nassim Haramein is on the forefront of a lot of this. Gosh, who are some of the Marco Rodin is doing some really good work. Jamie Beaufort's doing some really good work. And they all have lots of videos on YouTube, and we can link to some of those in the show notes, so people can continue exploring this on their own.
Right. I mean, that's all. The reason the podcast, we did this one, is just to introduce and literally get people to start looking into this more and expand upon it farther. And that's something that we plan on doing. And so once again, I mean, that's the whole purpose of the podcast. Don't take our word for it. Go look it to yourself, and go explore it for yourself, because and I know I don't want anyone to think that we have all the answers or not, because that's not the point of the podcast. But yeah, that seems to be the idea. I think that's enough to leave people with for now. I know there's a whole host of implications that this could open up. So I do hope people will look farther and expand upon this. Any last words, Jay, before we wrap it up?
The Earth is growing. How crazy is that? It's not just a rock that we're hanging out on. It's actually getting bigger. Right. That's amazing. This could be the key to free energy, all kinds of other things. If we can just grab hydrogen out of nothing, I'm down, man. I make too many trips to the gas station as it is. So maybe we all need to pick up a Rodin coil and start tinkering. The more people looking into this, the more people that are going to have some breakthroughs.
Right. Or, maybe it gets disproved. Either way, the goal is just to keep looking and keep finding things. And when they break apart, move forward. And if they don't, then looks keep pushing. But anyways, thanks again. If people want to contact you, what do you think would be the best way?
By the contact form on thelastAmericanVagabond.com. Just ask for Jay the Explorer, and they'll know who it is.
All right, perfect. And if anyone hasn't checked out The Last American Vagabond, please do. Got a lot of content that we're releasing. It's been a great project that's been growing day by day. So I do appreciate everyone who's been visiting, and anyone new, please encourage them to check out. If you like this video, share it around. We're just trying to get this information out and get people to, again, take it farther. So once again, thanks, Jay, for joining. And I do hope you guys tune in for another episode. Thank you.